So what I'm going to do now is the corresponding weak acid, weak base calculations. Again, at the end of the chapter 18, I've just picked a few relevant ones out. So I've got the new edition textbook, but I'm just find the appropriate question. Hopefully it's the same number. This is question 7. It says the dissociation constant of a monobasic acid at room temperature is 5.5 by 10 to the minus 5. So I'm told the Ka is 5.5 by 10 to the minus 5. And it says, find the pH of a solution of this acid containing 5 by 10 to the minus 2 moles in 100 centimetres cubed of solution. So 5 by 10 to the minus 2 moles in 100 centimetres cubed, that means I've got to bring that to a molarity. So remember, I'm going to put the moles over the volume in litres, and that will tell me the molarity. And when I put 5 by 10 to the minus 2 over 0.1, I'll get a molarity of 0.5. Okay, so it's 0.5 molar is my concentration. It has to be moles per litre. The other thing I want to point out to you is it says it's a monobasic acid. Monobasic means it only has one H plus for dissociation. Right then, so I've got to find, asks me to find the pH. The pH is equal to minus the log of the square root of the dissociation constant multiplied by the molarity. So that was the last slide that we had on the video. So the pH therefore is equal to minus the log of the square root of the Ka is 5.5 by 10 to the minus 5 multiplied by the molarity, which is this one here, 0.5. So when I do that, I'll get minus the log of the square root of 2.75 by 10 to the minus 5. And I'll get the square root of that, so this will just give me minus the log of 5.244 by 10 to the minus 3. And when I hit that into my calculator, I get a pH of 2.28. Okay, so that's the first one. Now I'm now going to jump down to number 9. Number 9 says the pH of a 1 molar solution of ethanoic acid is 2.37. So this time I know the pH, it's ethanoic acid, so it's CH3COOH. Again, that is a weak acid, so it's not going to fully dissociate in solution. CH3COO minus plus H pluses. It tells me what the pH is. It says the pH is 2.37. You've got to find the hydrogen ion concentration. So you've got to find the H plus concentration and show that the value of the dissociation constant is 1.8. So you've got to find the Ka and the H plus ion concentration. So first of all, let's find the H plus ion concentration. Now we know what pH is. pH is minus the log of the H plus concentration. I know what the pH is. It's 2.37 is minus the log of the H plus concentration. So that means that the antilog of minus 2.37, the antilog of minus 2.37 is equal to the H plus concentration. And when I hit that in, I get 4.266 by 10 to the minus 3. So that's my H plus ion concentration. Now, to find the Ka now. Now remember that the pH for a weak acid or a weak base is minus the log of the square root of Ka by molarity. And pH is also minus the log of the H plus ion concentration. So comparing these two things, it means for a weak acid or a weak base, so for a weak acid in this particular case, the H plus concentration is equal to the square root of Ka by molarity. Now that's very important. Make sure you remember that. So I know what the H plus concentration is this fella here, 4.266 by 10 to the minus 3 is equal to the square root of Ka by the molarity. Now it tells me in the question that the molarity is 1. It says that to me in the question. It's a 1 molar solution. So when I work this fella out, this will become 4.267 by 10 to the minus 3 is equal square root. I'm going to square this to release that Ka. So this will give me 1.82 by 10 to the minus 5 is equal to Ka by 1, which of course is just Ka. So the Ka is equal to 1.82 by 10 to the minus 5. So look, this is very important here. I want you to remember this, okay? The pH is equal to minus the log of the square root of Ka by molarity for a weak acid, and it's also equal to the H pluses. So they have to be equal then, these two things here. So that's very important, remember that. Now the other one I want to have a look at is, or I want to do with you, is question 11. Again, that exercise. So question 11, let me just that straight. Question 11 says you've got, it's actually urea, C2, let me just, H5NH2 acts as a base by accepting a proton. So it tells you in the question it's a base. You've got to calculate the pH of a solution. Find the pH of a solution of this that contains 1.5 grams in 250 centimeters cubed of water. And it tells you the Kb. This time it's the Kb because it's a base. Tells you in the question that the Kb is 4.4 by 10 to the minus 4. Okay. So, if it's a base, let's just write it, what happens to it when you place it in water. So it's C2H5NH2. So if you put it in water, it's going to accept a proton. So it's going to become C2H5NH3 plus OH minus. Okay, so I'm just writing the dissociation down. So remember that, that's important. So really this time I'm looking for the POH. So the first thing I'm going to get is the POH. And the POH, because it's a base, is minus the log of the square root of Kb by molarity. I have the Kb, but I don't have the molarity. So let's find the molarity. Remember, the number of moles is mass over relative molecular mass, which is 1.5 over. I've got 2 carbons, 24, plus 7 hydrogens, plus 14 for nitrogen. So that's going to give me 1.5 over 45. And when I work that out, I'll get 0.0333. That's the number of moles. So let's convert that to molarity by dividing it by the volume, which is 250, but I'll divide that by 0.25 into litres. So this is going to be, divide that by 0.25, and I end up with 0.1333 molar. Okay, so this is my concentration, molarity. I have the Kb, so let's get the POH. The POH is minus the log of the square root of 4.4 by 10 to the minus 4, multiplied by this molarity here, 0.133. So I'll hit that into the calculator, and I'll end up with a POH of minus the log. I'll get the square root of that. I'll multiply those and get the square root, and I end up with 7.659. You can check that figure yourselves. So the POH is equal to 2.116. Now obviously it was a base. I was told it was a base at the beginning, and it's POH I was working with. So remember to find the pH. My pH has got to be between 8 and 14. So the pH is going to be 14 minus 2.116. So that gives me a pH of 11.88. Okay, so that's number 11. There's one more I want to do. I'll put on the next video.